Okay, so today from the Id of Ed, I thought I'd go over the details of the construction of this control cabinet box for the stepper motor project. I'm going to put a bunch of files on Thingiverse that will cover the 3D printed components, the front and back of this guy, and the sheet metal parts that either come out with G-code on a CNC or hand drill them with a drill press and so forth to fold these edges and so forth. The idea being that if folks don't have sheet metal folding equipment, you can basically drill a series of holes here and allow the sheet metal to fold quite easily. And the project came out pretty nice. Originally I was going to do something out of just a little scrap box and so forth for this stepper control box for the for temporary run the mechanical calculator with a stepper motor rather than its original brush motor. And I thought it was a nice enough design that why not share this on Thingiverse. So basically this is just a video on just the control cabinet itself. I don't go into the electronics per se. There's been quite a few YouTube videos and websites on stepper controls and so forth that my stuff there would probably be redundant, and some of the components that I used are old components that you couldn't buy anyways. But you know, stepper driving is you know, a fairly simple thing to do. You can do it now with much nicer modern electronics, and the idea here is that the Thingiverse files will have various versions of simple blank 3D printed plates with no components in it, maybe some various versions with different fans and passive cooling slots on the front panel. But the expectation is you probably won't be doing a stepper control box. And odds are you won't need all these holes, but I'll have a version that's just a blank face, maybe a version with this LCD display and switch. I forgot in mind to get the holes for the vents. And also what I'll do is I'll put in there the FreeCAD files, the actual core files is where they generate all of these things. So you should be able to easily, if you have FreeCAD or want to try it out, it's really a nice open source program project, and it's come a long ways to the point where you can do quite a bit of impressive stuff. With this I was able to, you know, model these designs, and it now even has a G-code generator. It's maybe it's not as maybe polished or what I'm used to for commercial uses, but it's really quite nice, especially for free. And you know, maybe if this is sufficiently interesting enough to other folks, they'll come up with their own versions and maybe post them on Thingiverse too. It'd be interesting to see other people's take on this design. The idea is basically you can grow or shrink the length of the sheet metal section, put in whatever you want, and it seemed like it'd be good for maybe a control box for a homemade 3D printer, control cabinets for who knows what. You know, it's basically just a generic chassis that you can put whatever you want in it. You know, scientific instrument, your own homebrew power supply. You know, your imagination is kind of your own limit, I guess. For me, it was for a mechanical calculator, and hopefully folks that are looking at this video might be interested in taking a look at my videos on the calculator. It's been a kind of a fun project so far, and I'm getting close to being finished on it. So anyhow, so the big thing is Cad models, and I'll explain those next and kind of go through the actual steps of printing and drilling this guy and so forth and assembling it. And so hopefully you'll enjoy this little video. Okay, so here I am in the FreeCAD user interface environment, and I have a number of models opened up of my control box cabinet project, and I just thought I'd kind of go over a quick explanation of some of the files. The nice thing about FreeCAD is you can actually do fairly sophisticated assembly of components, and it's really handy for being able to kind of model up how things might go together. And I might do a video on that if anyone's interested on how to do that, because it's an area that I don't know if folks cover all that much. But I've made generic little models such as the display here for the LCD display that I believe is the LM20A21 LCD, or at least I got a little pin out of the explanation for that. I can't remember the name of it. It goes under several different Models, and that might not be the exact name of it, but I'll see if I can look that one up and put that in the descriptions a little bit more. I have a very crude model of my old stepper control module itself. That is a CMD50, quite an old model. If you happen to have one, that'd be kind of handy to use for your models. This is a model of the 24-volt power supply that I used in here. There's quite a few chassis models that look to be about the same size with different voltages and currents out there. Unfortunately, I didn't write down what the exact model of that is, but we could probably look that up too. McMaster Car is an unusually handy source for models. This is a fan that I just simply downloaded from their online catalog, and it's a, you know, if you want to do things like download some plumbing fittings, I downloaded like some national pipe thread unions, and they screw together nicely. They're not watertight or airtight or anything like that, but for a simple little structural project, they're actually kind of handy. This is a very crude power entry model, very crude fuse holder, and a very crude power connector. And you know, I just including those in case anyone wants to model their stuff after that. So if we get onto the actual blank cabinet that more likely folks would be interested in, it's basically the same thing. It's about 1 inch shorter, so that the assumption is that anyone that needed to print the paper prints out to hand drill the sheet metal covers, they'd be able to fit those on a 8.5 by 11 piece of paper. Mine, of course, is I did all the CNC drilling, and you might not have that, so that's the reason that's 1 inch shorter. And the whole idea behind the sheet metal section is you can expand it longer or shorter for whatever your project is. So really the big reference numbers are where those holes are at, for instance. And speaking of then sheet metal, the software in FreeCAD has all kinds of nice little modules you can download if you don't are not already in there. This one's a sheet metal modeling code, and it was very handy for coming up with the fold positions, and it'll flatten out the sheet metal for you and so forth. And then with that, with the folded sheet metal, I could then go into the path code that generates the G code and come up with a file version that drills all those holes. So something to kind of look into. This is the removable cover that goes on the top. Same thing again. It's sheet metal design and then flattened holes drilled in. Another thing to take into thought is the sheet metal. You can buy sheet metal at your home improvement stores, but it's usually like the maximum thickness is 25 thousandths. And I designed mine for about 32 thousandths, and for that you have to go to kind of a metal supply company, and most of those outfits are perfectly happy to deal with the general public. And for, you know, very modest cut fees, they'll cut your sheet metal to the dimensions you need. So in many ways, my little effort here at putting fiducial holes and so forth for getting this all cut out on a shear or any other home means of cutting out might not really be necessary. Just I would really just recommend not even going to a home improvement store or a hardware store. Just go to look up in your local area industrial sheet metal providers and see if they deal with the general public, and just order some 32 thousandths aluminum sheet metal. Take the flattened models, the PDF models, and just have them cut them to those dimensions, and then from there you can use the paper transfer and drill those holes out just fine. This is the generic version of the front cover. When you go to print the guy, have it oriented this side down so that your build surface is on this side, and it prints going up, and it'll print very nicely. I have various chamfers here so that the plastic doesn't droop as it were as it's printing. You'll have to tap 632 holes for all these locations. And if you're in the vast majority of the world where they don't use antiquated threads and fastener standards like they do in the United States, I can't tell you what exactly the metric dimension that would be, but I'm sure there's got to be something pretty close. Let's see here. Where am I at? Okay, so we got a lot of windows over here. I'm trying to go through all these guys here. So, okay. Hopefully not confusing folks too much. That is the back panel with, that I did for my project. A bunch of holes cut in it. Once again, my project with a bunch of holes already in it. I'll try and see if I got the time. I'll try and get a version that at least has the LCD display and the switch on it. But like I say, all this stuff for this project is going to be included with the FreeCAD software. So if you have FreeCAD on your computer, you can get it for Windows, Linux, and Apple. And I tried to be somewhat clear on the various stops here, so you can enable and disable some of these holes yourself, and of course add stuff and take stuff away and so forth. That's kind of the idea behind this, is that if you get kind of the source code, as it were, from the actual CAD, you're able to do so much more than just simply the STL files that I'll post. I've always found it difficult to modify somebody else's STL file for my project, so I'm hoping that this is helpful for other folks. The back panel, once again, obviously printed in that direction. I guess one thing to point out, I usually use repeater host only because it's kind of like one of the first 3D printing programs, control programs I happen to come across, and so I've been just using that, and it has some nice control features, I guess. But this particular file caused that program to crash. I don't know why. It'd be interesting to know if other people have troubles with it on any other motion control code for a 3D printer. I had to ultimately use my other old standby, which is Lesbot's edition of Cura, and it printed it just fine. I think that was like, I think it was at least 7 hours to print that guy, and you know, it's good for those few times I seem to have troubles, and every once in a while I have repeater host has problems. I don't know why. The back panel for my project printed out just fine with repeater host, though nothing unusual there. Say sheet metal, I guess that covers that. And I'll be going to a lot more detail on the sheet metal in the next parts of this video. Like I say, generic box. Hopefully you will find it useful for whatever your projects are. My box with a whole bunch of stuff in it, which I don't expect anyone to actually make a repeat copy of, but I'll put all those files in the Thingiverse posts, and hopefully you can kind of sort out the rather cryptic odd names I have for some of this stuff, and hopefully it won't be too confusing. And now we'll get on with the build of drilling and cutting out and folding the sheet metal and then assembling this guy, and hopefully you'll enjoy the rest of the video and you know, see how things are done in a different sort of way. So I have loaded in the mill a piece of sheet metal. It's 32 thousandths for the lower left side of the sheet metal part of the control box, and the idea here is I'm just going to drill a whole bunch of holes that will then form the edges, fold edges, and the mount hole locations. I'm kind of trying to design this so that maybe some folks that don't have like sheet metal folding equipment and so forth can make this cabinet easily. And this version, of course, isn't generic. It will have the components that are specific to my project, but I hope to put on Thingiverse the files that would be more generic for other folks in case you have a CNC. Of course, the other thought is via, I believe, a DXF or PDF file I should have on there. You know, stuff that you could print out on a piece of paper and then hand drill on a drill press. If you want to go through that much trouble, you could probably drill like half or quarter of these holes that are on this G code here, and it'd probably fold just fine. Maybe use a larger hole drill size. I'm using 81 thousandths drill bit, and in case you're curious, I'm running, it used to be called EMC. It's now called Linux CNC, and it's a really good open source motion control program that'll run your G code on pretty much any CNC. I think it's mostly still oriented towards computers with parallel ports. I haven't been keeping up with it as much lately. It could very well be that you can now do USB ports and so forth, and I know they can do servos and so forth. This is an old stepper drive system, and it's a little on the flimsy side. It's just made out of scrap parts. I got it at the scrapyard, in the early '90s, and I had to make my own motor control box. It's just a really old school LR circuit, current limiting control box. So I generate a lot of heat for very little power, but so it's not the most powerful machine in the world, but it does run. And it does a pretty good job. This thing will do a whole bunch of PEC cycles and drill it out, and we'll see how this goes. So let's give this a guy a try. It's going to be loud, so turn your volume down. I'm still new to using Cad G-code generator, and so it's going to generate a lot of PEC holes. I wasn't really sure a lot of how I was doing this G-code. I probably could optimize it more, but being I'm only going to make a couple cabinets, and I don't know how rigid somebody else's machine might be. It seems like a safe bet just to leave the PEC cycle in there and let people kind of deal with this PEC cycle, I guess. It's not that big a deal, I think, and it wastes a bit more time, but for a weak little machine like this, it helps out a little bit. So anyhow, I'll see you back here once it gets closer to being done. Okay, well, quite a few holes later. That's about a half hour's run. Not too bad, I mean, you just walk away and let the thing do its thing. The holes at the very corners, at the very extremes, I should say, are the fiducial holes. So if you shear this out with a shear or saw it or however you're going to cut it out, just aim for the inside edge, aiming in towards each of the axes, and plane it to that, or cut it to that, and that will be your finished shell. And then the idea is you fold at these points, and hopefully all will line up. There's always tolerance issues with 3D printed plastic and machine tools and everything, so we'll see how that goes. Here I have the drilled piece of sheet metal in the shear, and what I've tried to do is I've tried to line the outermost holes that are the fiducial holes for shearing the part. And the idea is that hopefully you can put like a 81 thousandths drill bit along the edge of this blade and where that hole is and get that line right. And it's proven a little fumbly with this cheap Harbor Freight combo roll and slip roll and pan brake and shear. And that's always been my hassle with sheet metal, is the sheet metal always wants to slide. You never quite get the alignment right. So I thought I'd try this, and it's maybe working. It might be easier to take a straight edge and, once again, maybe with a drill bit, find the edge of that hole and put a scribe, and then just do the usual alignment of the edges there and cut it there. But it's kind of handy to clamp it ahead of time. This is really light sheet metal, so it shouldn't be a bowls if you want to try and do that. And of course the idea is also you could tape this, glue it to a printed piece of paper to a your sheet metal and hand drill it if you want to drill that many holes. I think you'd probably want to do half or a quarter the number of holes, and it might still work. And it's still a crazy idea. Maybe it won't work, but I'd like to give it a try. I have this sheet metal folding equipment, and I still, after all these years, I don't use it very often. That's the problem, is I don't get that good at it. That it's kind of hit and miss as whether or not it gets folded just right or not. It's kind of one of those dark arts that nobody does much anymore, and I certainly don't do a whole lot of. I guess I'll shear it and see how it goes. Hopefully nice. Yeah, it looked pretty good. Went right across those edges, so I'll do that 4 more times. Okay, here is our 3D printed front panel, bezel, and it's obviously printed out for my project with all these extra holes. Indicator lights for no good particular reason, some override status switches for specific stuff for my calculator project, a single step button, a stepper speed, and a stepper strength. I'll use the current limiting resistor that they usually do to set the PWM pulse current strength on these nice PWM current limiting stepper drivers, and then LCD display for a lot of extra stuff that I probably really don't need for this project. I have a ton of these displays. I scrapped them out over the years, and so it's like always a case of gotta find some excuse to use them. And then the back panel is for a 24-volt fan I happen to have laying around. Had to use that, of course. Power entry, fuse, power plug for the stepper motor itself, and some I/O lines. And I'd say, for 3D, I must say 3D printing is nice. You can, if you kind of plan ahead on projects, you can just produce such nice results for very little effort. Modern technology is so nice these days. I wish people could appreciate and play with the stuff more, really, and rather than watch TV or do whatever they do these days. So here's the sheet metal part out of the mill. This is 32 thousandths. I have found that getting anything thicker than about 25 thousandths, at least in the United States, is at your local hardware home improvement store is kind of a challenge. They seem to only go to 25 thousandths, so I had to go to a metal supply place that I like going to, and it's actually quite a bit better bargain. You get a lot more metal for the money there, and most of these places are quite happy to deal with the general public. Unfortunately, my CNC, it's an old, weak machine, and I had set the feed override a little high. So unfortunately, I did lose some steps. It drilled a bunch of holes, did some other stuff, came back here, and you can see this doesn't line up. So it's always something. One of these days, I'm going to upgrade that CNC. And this one does have, a slight difference in the symmetry because of my project. These are holes for the power supply, and then holes for the stepper motor module. And I have to make certain that this side faces this side. So that's kind of my thing I got to look for. So the first thing to do is see if I can put these screws on and fold it. So rather than my fumbling around on the camera, I'll put these screws on and I'll come back in a moment. Okay, so I have the first couple sheet screws on the sheet metal part screwed to the plastic parts, and the hope is at this point you should be able to fold this to the actual finished dimensions and not have to have any errors from folding, and you don't need to use a special sheet metal equipment. At least that's the hope. And we'll see. This is a much heavier gauge sheet metal, like I was saying earlier, than most stores seem to have these days. So if you wind up having to settle for that, you'll find it a lot easier. And actually, it's more than enough. This is certainly doesn't need to be anywhere near this strong. So now that I've folded this, I'll take this off and I'll give it a little more fold past 90, and it'll conform a little bit nicer. So we'll be back in a moment. Okay, so I've taken it off and I've formed it a little past 90, and I think that tends to help a little bit on it staying a little bit truer to the shape of the part. And now I can put these guys back on again and then start the next fold. The other advantage, if you put a little bit of extra bend here, it'll bow into this surface, and then you can probably avoid putting some center screws in here. And you know, if you find that you need to do that, it's when you got it all assembled, and you can mark it and auto punch it and then drill it in place, and you know everything will then line up very nicely. So I'll put this back on these two parts and we'll do the next fold. Okay, so we got this side all nicely folded up, and hopefully we can get this to work again one more time here. So next thing is to see if we can fold it along this side and get that to line up nicely. I guess the problem here is it is a bit stiffer, so you got to kind of keep it from bowing out quite so much. It's kind of one of those things, if I was really wanting to do this right, I suppose I'd get some clamps and clamp this or screw this a bit. And you know, it's kind of like folding very, very stiff cardboard here. And I think basically once you've kind of broken it down to a basic shape again, you can then undo those screws, once again bend it a little past 90 and then put it back on again. So that's what I'll do, and I'll be back in a moment. Okay, so I've taken this guy out and I've bent it once again a little past 90. I guess it's kind of hard to see here. I guess I could tweak it a little more if I thought I needed it, but I think it's pretty much where I need it. So we'll see. I guess through the advertising, I found that the first fold, things must have slipped a little bit, so I still had to slot it. Very frustrating. The whole point behind this is to avoid these sort of things, and I don't know. It just seems to be, if you want it really snug, at least like I'm trying to do, it's kind of hard to avoid slotting. But you know, I have a little sheet metal, a little hand punch, and it's easy enough to just slot those back out again. The big thing is the initial holes get you really close to the dimensions you really want, and that's probably more important than anything. And in my instance, I use button head screws, so that will hide those slots very nicely. And then, as I kind of expected, the tolerances slowly shift on me, and I can see already that I'm going to need to slot these holes. So, you know, my CNC is good for plastic and wood. The large one, the small one would certainly do this, but the piece is too big. So, once again, I'll have to slot these, and then I'll fold the next sides. I've noticed that with the 3D printing, I have to compensate by about 15 thousandths on everything. Under, over, slightly like that to make everything fit quite right. And, you know, I've done things like the calibration blocks and everything, and it's still, for some reason, things are always off a little bit. So the debate is, when I go to post this on like Thingiverse, should I take that into account? Is it just merely my problem, somebody else's? I'm not sure. I could guess myself to death on this. It'll still be a really nice project. So I'll be back in a minute. Okay, we got it all folded up to this point and put back together. So now it's this last guy to fold. The one, of course, that has the lost steps. It couldn't have, of course, been this corner that, you know, probably nobody will ever see. But nope, it has to be that one. So, oh well. Let's move that up a little bit more. So this one, we'll see. I don't have as much mechanical advantage here. I can get this guy here without cutting myself. I did deburr those edges. It's definitely something to think about when you're doing this stuff, is to be careful. This stuff will cut you. Oh, this came out very nice. Now this is one of those things where, you know, I had done a previous shot of this project with the 25 thousandths stock I could only get at the local home improvement store, and I did, you know, at the end there, each time you moved it, folded it over, you had a little cumulative error, and so for this G code I did adjust these holes by 50 thousandths back, and so these really line up very nicely. So ironically, the ones that are more likely to cause the most trouble are the most spot on now, other than, of course, the very first ones, which would have been fine. Things hadn't slipped for some reason, I guess. Okay, so I'll take this off and I'll kind of do the same, fold it back a little bit and give it a little tweak or two and then put it back on, and hopefully this will look pretty good. And like I say, the 25 thousandths was more than rigid enough, but this 32 is crazy rigid at this point. Even at this point I can see that. And you know, I have a pretty heavy component that sits here, but even then the other stuff would have been more than sufficient, so I'm just being obsessive about this. Be back in a moment. Well, I'd say overall that came out pretty good. It's, even, as you might expect, even more rigid than the 25 thousandths I tried earlier. Like I say, this is more than it needs to be. The 25 would have been more than sufficient. I'm just being kind of ridiculous about this, really. You know, and even the flaw here, you really have to pay attention to it to even see it. Unless I was told it was there, I might not even notice it. I might consider putting a little bit more of a brush finish on it. You can do that with like a green Scotch-Brite, but it actually looks pretty good. The next question is, do I put all the guts in and then cut the drill and fold the cover piece? Do I do the cover piece next? I guess we'll have to stay tuned and find out. Okay, so the next run is drilling and cutting out the lid cover side for the stepper motor control box. And once again, this spindle is quite loud. Okay, so the CNC's all done, and we got all these holes drilled in this guy. Now I have to do some hand drilling with the drill press to open up some of the actual mounting holes, and then fold this guy up, and hopefully it all fits nice. Okay, so now we're back at the bench here with the calculator control box, and if you've been following this YouTube video series on the mechanical calculator, it's been running the calculator, and I'm just about to the point where I can get the division controls sorted out, and then I'll probably do a series of videos on exactly how the machine works as far as operating functions and so forth to a greater depth. But anyhow, so the sheet metal's all drilled. Kind of one of those design philosophy things. I designed this with 2 sets of screws on this side of the tray and only one on this side. I figured you had to have a little more access into the equipment on this side, but I wanted the cabinet to be reasonably stiff, so I added 2 sets of screws here, and from a aesthetic standpoint, I wanted the sheet metal to kind of go flush to the bottom rather than having kind of like a step where it would say mount with only 2 of those screws. So the philosophy here was I'd open up one set of holes to allow the heads of the screws to pass clear through, and you wouldn't actually have to remove those. Just for aesthetics, I wouldn't have actually a cut line right here, and this would have been the actual mount screw. It might make really more sense just to, dispense with these 2 lower holes, shear it all the way to that side, and just leave those holes, the clearance holes, for a 632. I just kind of went with, well, what would be, you waste a bunch of time doing, philosophy of what's the most aesthetic sometimes, and it can get a little silly, I have to admit. So, anyhow, so let's see if this all fits. So I gotta take off 2 screws and then see if I can fold this guy. looks like my clearance holes do go through. And I might still wind up trimming this, it looks like, because looks like my sheet metal does extend past the roll radius edge of the other side. Doesn't have quite the radius I'd hoped for, so it's one of those things when you're making the first and probably only one, you never know quite what to expect. What's nice to see it all comes out nice and flush along the plastic sides anyway. I was hoping to have that maybe closer to being a little more flush at the bottom. So I might trim this. It's a little, came out a little bit of a hook there. Okay, so got that. And this way I can avoid undoing those two screws. Like I say, it might make more sense just to really cut it here and just use those as clearance holes. I may play around with this some more yet. Looks like here we could. There's probably a little bit of play there, maybe. Maybe not. Okay. Be nice to put these other screws in before I fold it. Looks like I might actually have to slot these too. It's interesting that I can't quite get everything to just line up like it really ought to. So it kind of indicated to me that the printer is slightly out of whack. Or maybe the CNC is, I'm not sure who is. A few percent, you know, it can start to add up over a pretty good distance. So I guess what I'm going to do is the old slot technology. I need to go. Looks like I need to go slot these guys that away, so I'll be back in a moment. Okay, so I've slotted these guys a little bit. It's kind of unfortunate, you know, I put these printers and machine tools, and you think you could surely come up with something better than what you could do by hand, and sometimes it just seems like you still can't come out as good as you could. And I might even remake this guy and maybe dispense with the whole head hole clearance thing. I'm not really happy with that after all. So this might be a remake. Okay, so we got our piece of sheet metal in there. It's a little tight maybe. I'm going to fold this guy again just like before. And it's like a really stiff piece of cardboard. There we go. And then the other design philosophy was I decided that you probably, you know, it'd be nice to keep it as stiff as possible at the bottom, like having at least two screws always in place is the whole gimmick behind this. Whereas this side, I figured you can probably remove these two because you got two down here. So, whereas there's no mount screws underneath other than the power supply cabinet. So, or the power supply itself, I should say. Well, I guess I can just kind of put it through here. Okay, a little bit more. And those holes look like they line up pretty good. So what I need to do is take the sack off and bend it slightly past 90 and then tweak it back slightly, and then it'll seat on there very nicely. So I'll be back in a moment. Okay, so here I have the cover, the countersinks, and I'm going to do a little noise comparison between the cover off and the cover on. So here it is with the cover off, cover on, and that is quite a difference in noise. So I think that's a successful effort in noise reduction at the very minimum. Well, I think that's pretty much a done deal on this little project here. I'll put on Thingiverse the 3D print files for the front and back and various versions with and without population of various holes for components, and then the sheet metal parts, G-code, and PDF files for hand drilling and so forth. And, you know, the expectation really is that folks can use this design for whatever they want. You know, I'm certainly not expecting people are going to do a stepper control box system for a old mechanical calculator, but, you know, it seemed like it was a nice enough design for, you know, control box for a 3D printer or power supply or some sort of scientific instrument or what have you, whatever your hobby project is. So look for various versions of the files with cutouts for LCDs, switches, fans, and then, you know, if folks are interested, I can probably add some more over time, or maybe other people might want to modify this design and add more stuff and post their versions. Anyhow, at least for me, it's stepper control for a old mechanical calculator. And I'm getting close on the calculator, so if you're interested, stay tuned for some more episodes of trying to figure out the problems on this guy and get it all sorted out. Anyhow, that's it from the It of Ed, and thanks for watching.